Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at Euclidean geometry, proving that a line is a tangent to a circle, and we're also going to prove that two triangles are similar. The question that we're going to be looking at is from the November 2018 paper 2, and it reads as follows. It says here that in the diagram, ABCD is a cyclic quadrilateral, such that AC is perpendicular to CB and DC equals to CB. AD is produced to M such that AM is perpendicular to MC. Let B equals to X. Now, when you read a question of this nature, it's important to read it a few times because you need to sift out the important information, like cyclic quadrilateral. If two lines are perpendicular, there's a 90-degree angle between them. DC equals to CB and AM equals to MC. Let B equals to X. So let's go look at the diagram and check whether everything is there. So when you look at this diagram, you'll be able to see that A, B, C, D is a cyclic quadrilateral. Therefore, you can see that the exterior angle there, that's going to be equals to X. Exterior angle equals to the interior opposite angle. What else do we see? We see here that BC is equal to CD, and those are equal chords. And remember, equal chords subtend equal angles at the circumference. Therefore, A2, that's going to be 90 minus X, sum of angles of triangle. Therefore, A1 will also be 90 minus X. Remember, equal chords subtend equal angles at the circumference. Now, let's go and read the question. So if you look very carefully, it says, prove that MC is a tangent to the circle at C. And when you have to prove that MC, a line is a tangent at a particular point to a circle, so we want to prove that MC is a tangent to the circle at C. So what we have to do is look at one of these ways of proving it. So you can either prove converse tan chord, you can prove converse that the tangent is perpendicular to the radius of a circle, or converse, you can prove tangents drawn from the same point are equal in length. So let's go and see which one of these ways we can prove that MC is a tangent to the circle. So if you look very carefully, what do we have here so far? MC. So if I look at it now, I got that A2 is equal to 90 minus X. M1, I've shown that it's equal to 90 minus X. So let's find one of these angles here, or let's find anything between the tangent and the chord. Now, if I look at this particular triangle here, which is AMC, what do you notice? You will be able to see that if that is 90 minus X, and that is 90 degrees, then MCA, or you can say ACM, or you can say C1 plus C2, that whole angle is going to be equal to X. And you can now conclude this angle between the tangent and the chord AC is equal to angle B, which is the angle in the alternate segment. Therefore, MC would be a tangent at C. So let's go write our solution down. 10.1.1. First thing that I'm going to write down is A2 equals to 90 minus X, sum of angles of triangle. A2 equals to 90 minus X, sum of angles of triangle. Then I'm going to write down the next thing that I said, which is A1 equals to A2 equals to 90 minus X. Equal chords subtend equal angles at the circumference. A1 equals to A2, that's equal to 90 minus x, and my reason will be equal chords subtend equal angles. And thereafter, the next thing that I said was that ACM, or you can say MCA, we're looking at C1 plus C2, the angle between the tangent MC, which we're now going to prove, and the chord AC is equal to X. So let's write that down. ACM is going to equal to X, and our reason will be sum of angles of triangle. If you want here, you can write which triangle you are referring to. So you can say in triangle, and there's it there in pink, AMC. We've already highlighted it. In triangle, AMC. Therefore, what can we conclude? Therefore, ACM will equals to B, which will equals to X. Our conclusion, therefore, MC is a tangent at C, and this is very important, converse tan chord. And that's our solution. MC is a tangent at C, converse tan chord. Let's go look at the next question. In the next question, it says that we need to prove that triangle ACB is similar to triangle CMD. Now, how do we prove that two triangles are similar to each other? Well, there's two ways. So for similar triangles, let's just write that down, 10.1.2. So for similar triangles, you can either prove that the two triangles are equiangular, or we can prove that the two triangles have their sides in proportion. Remember, if we prove that they are equiangular, then their sides will be in proportion. If we can prove their sides are in proportion, then they will be equiangular. It's important to note that with similar triangles, these two triangles are not identical. Identical triangles are in congruency and not in similarity. So let's go and look at the two triangles, ACB and CMD. So ACB be the following triangle. So ACB is that one there. Let's look at a different color for the other one, which is CMD. CMD is this triangle here. Let's see, what do we have? So let's write the obvious ones down first. If you look at the both triangles, they both have a 90-degree angle which was given to us. So that will be one statement. We only need to show that two angles in one triangle and two angles in the other triangle are equal to each other to prove similar triangles. The third angle will be because of the remaining angles. Sum of angles of triangle add up to 180 degrees. So my first statement will be that 90 degrees. My second statement will be D2 equals to B equals to X, exterior angle of a cyclic quadrant. And then if you look very carefully, X and 90, so that's 90 minus X, remaining angles. And we've already shown that A2 is 90 minus X. So we've got our three angles. So how do we structure a similar triangle? Now, we will say in triangle ACB, so we'll write down our solution as follows. In triangle, write that down, ACB, and triangle CMD. Statement number 1 would be that ACB is equal to CMD or DMC, equal to 90 degrees. ACB equals to CMD equals to 90 degrees. And remember, that was given to us. How was it given to us? We are told that AM is perpendicular to MC and AC is perpendicular to CB, and it was also drawn on the diagram for us. Second statement. In the second statement, we're going to write D2 equals to B, and that's the exterior angle of cyclic quad. Remember that the exterior angle of a cyclic quad is equal to the interior opposite angle. Statement number 3 will be that C2 is equal to A2 equals to 90 minus X, the remaining angles. So we'll write that down. C2 equals to A2, that's equal to 90 minus X, and that's the remaining angles. Remember, because the sum of angles of a triangle add up to 180 degrees, there are only 3 angles in a triangle. Therefore, triangle ACB is similar to triangle CMD, and our reason will be angle, angle, angle. And that's our answer to question 10.1.2. Interesting thing for you to note, that if two triangles are similar, and now to answer any question that may follow this question, remember that if two triangles are similar, their sides are in proportion. So this is what you can now write for any remainder or remaining questions that will come after this. AC, first 2, over CM will equals to second 2 letters here. Remember that we are writing our triangles in the order of their angles. So CB all over MD will equals to, remember the first and the last letters there is AB all over CD. And now you can answer any questions to find lengths or distances from here. That is, if you haven't subscribed already, remember to subscribe to JL Maths, and also check out all the videos, jlmaths.com, like my Facebook page, Justin Lazarus Mathematics, and I'll catch you in the next video.